So on to question 3, and we're doing a bit of factorising now, so the opposite process of distributing that we just worked on. The first one here, we're looking at these two numbers, 18, and we're subtracting from that 8b. We think about the factors of 18 being 2, 3, 6, 9, and over here we've got factors being 2 and 4 as well. But on that we take a look, we go, well, 2 is the highest common factor out of these two. Given that this is 2 times 9, and this is 2 times negative 4b, 2 comes out the front, we've got 9, we've got negative 4b, and we're done. Again, over here we've got 2 even numbers, so 2 is definitely going to be a factor. We might consider, obviously 5 is not going to be a factor, but the giveaway is this number here. It's 2 and 11 as our factors. There's not going to be another factor in there, so again, 2 is our highest common factor. If we divide this term by 2, we end up with 5d, and if we divide this term by 2, we get 11. The great thing about these ones is you can always distribute these to check if you've got the right answer. Let's go ahead and do these last couple. So in this case here, we've got some pronumerals in here. You can see that's the first thing that stands out, that we've got y in each of our terms as factors. And if you take a look at the coefficients, you can see that 4 will be the highest common factor between these two. So we're going to take 4y out as our highest common factor. If we divide the first term by 4y, we're left with just the x. And if we divide the second term by 4y, that will give us 6. We won't have the y, we'll just have the z, so it's just 6z. And we've factorised our third question. The last one here, very similar. We've got 40h, so we're going to have 10 is going to be the highest common factor, as well as h. So because we're taking 10h out of this first one, we divide that by 10h and we're left with just 4. There's no pronumeral now. And if we divide 10h in here, the 10 and the h go away, we're just left with the t. And there's our final answer. Okay, so we're on to probably our most challenging skill that we've learnt in this term. We're going to be factorising and then simplifying. Now, factorising and simplifying, they're kind of opposites. Usually we'll get rid of brackets, that's what simplifying means, and factorise means often throwing brackets back in. So we're going to factorise and we're going to simplify, and you'll see how that works out in this case here. Basically, the factorising is going to make this expression look a lot easier. If you take a look at the first, above the vinculum here, a numerator, we can take a look and you'll see that 5 is a common factor in that term, so we're going to factorise that out. And if we divide 5a by 5, we get a, and negative 5 divided by 5 will give us negative 1. On the bottom, you'll see here the common factor is 8, and when you divide that first term by 8, you get a, and when you divide this one here, you get negative 1. Now here's the main thing, and this is the reason we're doing this, is that we've got two factors here that are exactly the same. And imagine that a was 9. 9 take away 1, 9 take away 1. You're going to have 8 and 8 as factors, you're going to be able to cancel those out. Even if a was an irrational number like pi take away 1, pi take away 1, once you divide those by themselves, you end up cancelling those, and we get our final answer, which is just 5 on 8. For the next one here, we're going to do a similar process. So I'm going to go down the page this time. It's going to try to line these up as I move down. This first term here, I've got 5 as a highest common factor, so 5 is going to come out, which is going to leave me with y minus 3 above the vinculum. On the bottom, 2 is going to be the highest common factor, so we've got 2 lots of y plus 4. And you'll see, when we multiply that by y plus 4 over 10, we can start cancelling here. These two factors cancel out straight away. The other one we've got a common factor here as well. Okay, so 5 is a common factor. So So that will leave us with 1, and that will leave us with 2. Let's clean this up and see what it looks like. So on the top, we've just got one lot of y minus 3 times 1. So y minus 3. And on the bottom, we've got 2 times 2, which leaves us with 4. Okay, so for this next question, you might want to think that you've got some common factors here, but the vinculum is a grouping symbol, which means you have to do this action before you do the divide by 4. And because we don't know what a is, we can't work out what a plus 2 is, and therefore we can't divide it by 4, and we don't know if 4 is going to be a factor in case. Same over here, we can't work with this 6 until we work with this part on the top here. Okay, so let's just go ahead and check this step by step as we did the previous questions here. And the first thing we're going to do, the question tells us, that gives us away by saying factorize. So let's do that. 3 is the highest common factor on the top here. That leaves us with a plus 2. And that's going to be divided by 2. What I'm going to do now is, when you divide a fraction, the way we treat that is we multiply by the inverse, or as I like to say, switch the symbol and flip. So keep, switch, flip. And you'll see this does some really nice stuff for us because we've got an a plus 2 on the bottom here and an a plus 2 on the top. Because they're grouped, we can cancel those out. And we've also got 2 even numbers here, so we can cancel out the 2 by dividing by 2, cancel out the 4, and it leaves us with 2 when we divide it by 2. And what have we got left? We've got, on the top, we've got 3 times 2, and on the bottom we've got 1 times 1. So that's just going to leave us with 6 as our final answer. So this final question looks complex, and it is, but if you break down each individual little piece, it's nothing you haven't done before. So if you can treat this piece by piece and work through it methodically, just like you've done the previous ones, you're going to be able to achieve this no problem. So let's just take a look. In our first one here, we're just going to consider what's above the vinculum, nothing else. Okay, just in the first product, what's above the vinculum. And you can see here we've got 4 as a common factor. We've also got p, that's p times p, but this is just p, so we can take one of those p's out. And we've also got q as well, in a similar way. So let's just do above the vinculum for this first product here. So we said 4pq is all common to both of those terms. If this first term is divided by 4pq, we're left with, well, that's gone, one of those is gone, and one of those is gone, so we're just left with p. And if we divide this by 4pq, well, the 8 becomes 2. The p comes all the way out this time, and we're left with one of these q's just staying behind. The bottom term, not much we can do there. There's no factoring, there's no common factors there, so that'll just stay as it is. But let's take a look at this next piece here. So we'll put a multiplication symbol in, set up our vinculum. You can see here 2 is a factor. No need to worry about the pronumerals in this case. 6 divided by 2 will leave us with 3, and the h comes along. And on the bottom here we've got 2pq. Now that's going to look really good. We're going to be able to do a lot of work with it. Get rid of some of those things real quickly. Again, we see a divide symbol come up, so we keep this first part, we switch the sign, and we flip our final one. Now I might just do that and we'll factor that in a minute. Let's just do the keep, switch, flip for now. But while we're here, we're going to take a look at some of these other things that we can make our life a bit easier. You can see here the f plus 3h, and there's a f plus 3h in brackets. Got rid of those. PQ's here, the PQ's here, gone. And we've got 2 divided by 2, which is all going to give us 1. This whole thing has become 1. Let's just rewrite, just to neaten things up. And if you didn't choose that order straight away, That's no problem. You can choose a variety of different orders with this. So we've got 4 lots of p minus 2q. That's going to be just over 1. And I'll leave it as a rational number for now. Multiply by 1, so I'm not even going to bother writing that. Multiply by 1, a bit of a waste of time. And over here, now I'll do the factoring of this bottom term. I've only got 2 as a highest common factor, and then I've got p minus 2q. And as we factorize that, you can see here we've got these two, p minus 2q, gone. This is 2 times 2, and there's 2 here, so we can divide 4 by 2, and that will leave us with 2. And all we've got left is 2 times 7 over 1, which is 14. So this horrible mess of an algebraic expression has ended up quite simply being the number 14.